Hello everyone, in the last lecture we have studied two types of compiled time polymorphism, that is function overloading and operator overloading. Now we are going to see one more scenario where compiled time polymorphism is achieved or early binding is happening. But to understand or to implement that concept, we need to understand pointer to base and pointer to derived. We can have a pointer to base class pointer and pointer to derived class pointer. Base pointer can point towards the base class as well as derived class. We can assign the address of base class object, or we can assign the address of derived class object to base class pointer. Now, although base class pointer can point towards derived class, but it can access only those features of derived class which are common in both cases, means only inherited features from base. Hence, base class pointer cannot access the specific features of derived class directly. If I come to the example, see here I have defined a class base with two member functions. First is your void base function. There I have displayed a simple statement in base function. Next is your void display, where I have displayed a simple base class code. Now coming to the derived class, that is derived from the base. Now again, if you see here, display function here also, display function here also. But if you see here, I have void derived function and here I have a different one. So your base class pointer can access only those members which have which are inherited, which have same name as that in your base class. Basically the concept of overriding or redefined in derived class. Now if we want to access the specific features of derived class with the help of base class pointer, then we need to typecast it with the derived class pointer. This was all about base class pointer. The last point is basically for derived class pointer. What is written regarding that? Derived class pointer can point towards derived class only. We can assign address of only derived class object to derived class pointer. If we try to assign address of base class object to derived class pointer, then error will arise. Now let's move to the example. So what I'm going to do is, what we need to create base class pointer. Now this is a similar concept. Now I'm going to deal with the main function like we have done pointer to object. For base class B object, and this is your pointer of base class type. Derived class D its object, and B is the pointer of the derived class. Now what is this? Pointer to object means my base class pointer is holding a object. What type of object it is? Base. So if I'm going to call it, if you remember, arrow operator, pointer to member operator, we use it with a pointer. Now pointer, arrow base function, pointer, arrow display. Now program will work fine. What will be your answer? In base function and base class called. If I execute this, see here what is the output. In base function, base class called. Now what I'm going to do is, my base class pointer is going to hold derived class object. Now what was written here? If we want to see here, although base class pointer can point towards derived class, but it can access only those features of data which are common in both the classes. If I execute this line, see, because it had not defined, you see what is there? Base class has no member name derived. So this is not going to work, and we have started this thing earlier also. This will work because here also display and here function is redefined. What is polymorphism? using one form into many forms. Now, display function, according to you, what should be the answer? In base function, base class called for these two, and for this derived class called. But see actually what is the answer? See here. In base function, base class called, base class called. So why is it so? It is because of the static binding or early binding. Now at early binding, what happens? The compiler just sees the type of the pointer, not what is the content in the pointer. So pointer is of which type? Base class type. So even if your pointer is pointing to display function, it is holding the address of derived class. The pointer is of base class type, it is going to call display function of base class. Next is, what I'm going to do is, now my derived class is going to point to derived class pointer. Now this thing will work fine because it is pointing to its own object. So here, no problem. Here, what will be the answer? In derived function, derived class called, because pointer is of which type? Derived class. Okay, in derived function, derived class called. Now, what is this one? If you want to assess the specific features of derived class with the help of base class pointer, then we need to type first it to the derived class pointer. Now see here, I need to typecast. Now if you remember, in case of void pointer also we did the typecasting. How to typecast a pointer? Derived star in my pointer name. What is the derived here? Derived. Your asterisk symbol. Here is my base class pointer, arrow, and your derived function. Similarly, your just statement. What will be the answer here again? In derived function, derived class. If I execute this, see, in derived function, derived class. Now, what was the last point that we have covered? That derived class pointer can only point towards derived class only. It is not going to point to the base class object. Now, what is the base class object and what is the derived class pointer? If I execute this, see, it is not going to. That is all about pointer to base and pointer to derived